Let's see how to write all the terms in the expansion of 2x plus 1 raised to the power of 5. Well, just as in our previous tutorials, we can start by comparing what we have here to the left-hand side of the binomial expansion's formula. And in doing so, we quickly see that the only difference is that we've replaced a by 2x, b by 1, and n by 5. So to get us started, we can copy the right-hand side of our formula, replacing every a that we see by 2x, every b by 1, and every n by 5. So we can write that this equals to the sum from r equals to 0 up to 5 of the binomial coefficient 5r times 2x, which I write in parentheses, raised to the power of 5 minus r, times 1 raised to the power of r. And the sum that we have here is as far as our formula will take us. Now, before diving in and writing all the terms of the expansion, I like to spend a minute or two to simplify the expression that I've just underlined in green. This is the general term of the expansion, and I like to call it t of r. And let me just copy that on the side here. So we have t of r, which equals to the binomial coefficient 5r, times 2x in parentheses raised to the power of 5 minus r, times 1 raised to the power of r. Now this can be simplified. Indeed, the first thing I notice is that we have 1 to the power of r here. And it doesn't matter what r is, when we raise 1 to any power, it will always equal to 1. In other words, this just equals to 1 and we can ignore it completely. The next thing that deserves attention is this power of 5 minus r. Since the 2 and the x that are inside the parentheses are being multiplied, this power of 5 minus r distributes onto both the 2 as well as the x. In other words, this general term, t of r, equals to the binomial coefficient 5r times 2 raised to the power of 5 minus r times x raised to the power of 5 minus r. And that's our general term simplified. Okay, back to the sum. Since we called this expression t of r, we can say that this sum from r equals to 0 up to 5 is equal to t of 0 plus t of 1 plus t of 2 plus t of 3 plus t of 4 plus t of 5. And each of these terms, t0, t1, t2, and so on, is obtained by replacing every r that we see inside the expression for our general term by its corresponding r value. And here's how that works. For t0, we replace every r by 0. So that would be the binomial coefficient 5, 0, times 2 raised to the power of 5 minus 0 times x to the power of 5 minus 0. We add on to that t1, for which we replace every single r by 1. So that's the binomial coefficient 5, 1 times 2 raised to the power of 5 minus 1 times x raised to the power of 5 minus 1. We add on to that t2, for which we replace every single r by 2. So that's 5, 2 times 2 raised to the power of 5 minus 2 times x raised to the power of 5 minus 2. And we add on to that t3, for which we replace every r by 3. So that would be 5, 3 times 2 raised to the power of 5 minus 3 times x raised to the power of 5 minus 3. We add on to that t4, for which we replace r by 4, so that's 5, 4 times 2 raised to the power of 5 minus 4 times x raised to the power of 5 minus 4. And finally, we add t5, for which we replace every single r by 5. So that's the binomial coefficient 5, 5 times 2 raised to the power of 5 minus 5 times x raised to the power of 5 minus 5. And at this stage, we've written all of the terms of this expansion. But we can't stop there. We still need to simplify each of these terms as much as possible. So to get started, let's take care of all these powers of 2 and of x that we see in each of the terms. In the first term, we have 2 to the power of 5 minus 0, so that's 2 to the power of 5, which is equal to 32. And that multiplies x to the power of 5 minus 0, which is x to the power of 5. In the second term, we have 2 to the power of 5 minus 1, which is 2 to the power of 4, and that's equal to 16, and that multiplies x to the power of 5 minus 1, which is x to the power of 4. In the next term, we have 2 to the power of 5 minus 2, That's 2 to the power of 3, which is equal to 8, which multiplies x to the power of 5 minus 2, which is x to the power of 3. We carry on, we have 2 to the power of 5 minus 3, which is 2 to the power of 2, and that's equal to 4, and that multiplies x to the power of 5 minus 3, which is x to the power of 2. For the next term, we have 2 to the power of 5 minus 4, which is 2 to the power of 1, which just equals to 2, and that multiplies x to the power of 5 minus 4, that's x to the power of 1, which is just x. Finally, in the last term, we have 2 to the power of 5 minus 5, that's 2 to the power of 0, which equals to 1, and that multiplies x to the power of 5 minus 5, which is x to the power of 0, which is also equal to 1. Remember, any non-zero number x raised to the power of 0 will always be equal to 1. Now that we've taken care of all the powers of 2 and of x in our expansion, we need to find the values of each of the binomial coefficients that we have. And for that, we can use the tricks that we learned in our previous tutorials. Remember, the first and the last binomial coefficient will always be equal to 1. So we can go right ahead and say that 5, 0 equals to 1, as well as 5, 5. Done. The next important result is the fact that the second coefficient as we go from left to right, as well as the second coefficient as we go from right to left, so those are 5, 1 and 5, 4, will always equal to the power to which we're raising the binomial. So in this case, that's 5. So without thinking, we can state that 5, 1 equals to 5, and 5, 4 equals to 5. The next important thing to remember is the fact that the values of the binomial coefficients are the mirror images of each other across the middle of the expansion. So for this expansion, that tells us that the third value as we go from left to right is equal to the third value as we go from right to left. In other words, the binomial coefficients 5, 2 and 5, 3 are both equal. And so thanks to those well-known results, we only need to calculate one binomial coefficient. And we'll go ahead and calculate this one, the 5, 2 that we have here. And we do so using the binomial coefficient formula. So let's go ahead. I'll do that in the right-hand corner here and state that the binomial coefficient 5, 2 equals to factorial 5 over factorial 5 minus 2 times factorial 2. That's equal to factorial 5 over factorial 3 times factorial 2, and that's equal to 5 times 4 times factorial 3 over factorial 3 times factorial 2. Now the factorial 3's cancel each other out, and factorial 2, well, that's just equal to 2. So this is equal to 5 times 4 over 2. And you can go ahead and check, but that equals to 10. So going back to our expansion, we can now state that the two middle coefficients 5, 2 and 5, 3 are both equal to 10. And now that we've calculated the values of each of the binomial coefficients, we can go ahead and state our final answer. Indeed, we can now write that 2x plus 1 raised to the power of 5 is equal to 1 times 32 times x to the power of 5, so that's 32x to the power of 5, plus 5 times 16 times x to the power of 4. Well, 5 times 16 is 80, so that's 80 x to the power of 4. We add to that 10 times 8 times x to the power of 3, so that's 80 x to the power of 3, and we add on to that 10 times 4 times x squared, so that's 40 x squared. We add on to that 5 times 2 times x, which is 10x, and finally we add to that 1 times 1 times 1, which is just 1. And we're done. We've just written all of the terms in the expansion of 2x plus 1 raised to the power of 5 using the binomial expansions formula. In our next tutorial, we work through another example in which the x inside the pair of parentheses is raised to some power. So do make sure to watch it to learn how to deal with that. For now, though, that's it for this tutorial.